Do you want a cord? You want a cord to go from there? Do you want a mic me?
No.
Okay.
Hey everybody, Brett Little here, Executive Director at the Green Home Institute. We're in Chicago at McCormick Place at the Chicago Build Conference for the second and final day. And I'm here with our supporters and sponsors, TSTUD, and the owner of the company, Brian Iverson. So we're going to turn it over to him and have us kind of take us through some new stuff he's got going on to help you save energy and money behind your walls.
Hey, thanks, Brett. So, this is the lowly 2x6. I know I couldn't have picked a uglier sample, but it's still the value, still holds 2,200 pounds in axial compressive loading. Because we solved the ability of the board to deflect in this X dimension, right? So you put a load on it, this load deflects the board, bends out of deflection, and breaks. We turned the board perpendicular, so we stopped the ability of the board to deflect. So now we're just like the tree standing in the forest. So we're certified to hold 8,600 pounds. And then we built a truss out of it, and we injected a HFO blowing agent, class 1 foam into the middle of it. So as a top plate, that's how we burned. So we still had 96% or 90% structural capacity left over after the test. Versus the lowly 2x6, that's all that was left. That's why a fire department can only go into the attic if the wall has been compromised for 10 minutes or less. After 10 minutes, they can't go into the attic. Just a little food for thought there. Okay, so we went with the HFO blowing agent because it's hydro, HFO, I forgot what it stands for. O is Ole for olefin versus HFC for carbon. Right, HFC 800 to 1300 is the global warming potential of it, and we are less than 1. So Ole butter, don't eat it. Okay, so that's our products that we have. This is the TSTUD wall assembly over here. We went back to the 2x6s for the top plate because there are a lot of people who didn't want to use a 4-inch nail gun, and they wanted to figure out the math. So I did it. We only make the whole entire wall assembly 3% more energy efficient if you use the TSTUD for the top plate. I didn't say that you reduced your heating and cooling bill by 3% because I don't think it reduced it by anything. So for the return on investment for the wall and for your owner, you probably just stick with the 2x6s for the top plate. I know I'm not selling as much TSTUD material, I got that. But we also represent the wall and the client and the actual owner of the property. The net zero people and the passive house people, I can assure you that they are going to use the TSTUD for the top plate because they want the complete thermal break through a whole entire wall assembly, no matter what it is. It just happens to be maybe about 1/4 of our cost. So anyway, just trying to give you everything. So. Spray foam, everybody's got their idea. This is a bare naked TSTUD with spray foam in the middle of it. Obviously the overall R value of this wall assembly ended up being 35. So we're actually spraying in foam in our first bare naked TSTUD house in St. Paul today. So that's pretty exciting. So this is what they're gonna get. Their air changes per hour, they're thinking are gonna be between 0.25 and 0.6 per hour without even trying. So pretty impressive. But even if you do spray in or blow in, this is the bare naked TSTUD design now. Obviously the foam in this one, this is 40% of our strength because of how we have to do the bending test. So in order to pass the test, so that you could put in cellulose, mineral wool, fiberglass into the middle of it, I had to turn this member perpendicular. This isn't the end design of it. We're actually going to scooch this board member over to make it easier to frame with, okay? But our overall R value with cellulose in this is over 9.5. You put fiberglass in the middle of it, it's over 11.5. You do spray foam, we're almost to 16 into the middle of it, versus obviously the full TSTUD we got to an R value of 20. So our goal as a company is to make your structure more energy efficient for the life of the structure. No maintenance required once it's in the wall. So you got to kind of decide how you want to spend your money you want to spend it on mechanicals that every 8, 10, 15, 20 years you have to replace all the mechanicals, or do you want to spend a few extra dollars in that wall? So in 5 minutes or less, that's probably the best I've ever done at telling this story. Okay, thank you.
All right.